lecture, we're going to continue going over input and output in MATLAB, and specifically we're going to look at output and interfacing with Excel. So what are we going to learn to do? We're going to compose meaningful and formatted statements to display solutions in the command window using our fprintf command. We're going to store formatted information in a variable for future use by using the sprintf command, and we're going to correct the output of numeric and text commands to control the way it's being displayed. So what does the DISP function do? It displays the variable. So the variable that you're inputting is what you want to be displayed. It cannot display text and the value on the same line. It uses the default numerical display format with no ways of changing it. It's generally not recommended for formatting a final output if you want something to look nice and pretty. It's useful for debugging or getting a quick and dirty output during the development of a program. Then we have fprintf. It creates a formatted text string. It controls the display output. The inputs to our fprintf command are the string that we're trying to print and the variables that we would like printed in the order that they appear. The backslash is used to signify a special control. Special controls are adding new lines or adding tabs. So \n inserts a new line. So if I do fprintf hello, it's going to print the word hello and then go to the next line. \t inserts a tab. So if I do fprintf a \t b \t c \n, it's going to go a tab b tab c and then go to a new line. Double backslash inserts a backslash, similar to our apostrophe, which down here is 2 single apostrophes as a quotation mark, and to get the percent symbol you have to hit the percent symbol twice. That is because backslash, single quotes, and parent sign are all commands that do other things in MATLAB. So using fprintf, when the percent character occurs in the formatting string inside of fprintf, it means to insert a value here using the formatting code immediately following. What does that mean? Well, we have %f, we'll insert the value shown to 6 decimal places. So if we do fprintf in %f, var, it's going to display our variable var to 6 decimal places. If I do %0.mf, it's going to insert a fixed value of decimal places. So in this case, if I do %0.1f, it's going to display my variable var to 1 decimal places. If I do %n.mf, it's going to insert a field with width of n spaces before your variable containing n decimal spaces. So this is displaying 8 spaces before the word before the variable is displayed to the 2 decimal places that we described. It is note that this is a field width, not a complete space, which is why there's not as many as the number 8. If you do %0n.f, it inserts a field of n with the zeros containing m decimal places. So we put 3 leading zeros before our variable here. %e or capital E, lowercase or capital E is going to insert the variable in scientific notation, and you can combine these. For example, fprintf %0.3e will display in scientific notation with 3 decimal places because I'm combining my 0.m and my %e. %s just inserts text. So let's look at an example. If I have a variable that says my val is equal to 5, and I want a string to say fprintf of y plus 0.0f of my val, what it is going to do is it's going to display y plus 5, because it is going to format the 5 to have 0 decimal places. If I have pi is equal to pi, comma 0.1 times pi, 100 times pi, and 10 to the 8 times pi, and I insert the command fprintf of %0.7f slash t, %15.7f slash n, %0.10, 0.10, %010.1f slash t, %0.5e slash n, comma pi. What is it going to do is it's going to format the first entry in pi to 7 decimal places. Then it's going to put in a tab. Then it's going to format the second entry into pi with 15 leading character widths in 7 decimal places. Then it's going to go to a new line. Then it's going to put in the third entry of pi with 10 leading spaces worth of zeros and 1 decimal place. Then it's going to put in a new tab, and then it's going to put in the last entry in pi to 5 decimal places in scientific notation. So sprintf creates a formatted text string that's stored in a variable. It does not display an output on the screen. That is the main difference between sprintf and fprintf. So if I type in my val equals 5 and I take my same command that I had previously and I change it from fprintf to sprintf, my variable mstr is going to contain the text string y plus 5. It's not going to display to the screen. If I want to insert a variable that is text into this, I'm going to use my sprintf command, start typing my string. So the %s means put in text, balked. Tval is what is the variable that is going to go in where this %s is, and that variable contains the word hero, so it's going to contain the text string the hero balked. It can create special characters for inclusion on figures. Most special characters will not work correctly if printed in the command window. So if I want to get alpha and omega to print, I can use my sprintf command, start my text string %s to %s, close my text string, and then put in the variables that I would like to have one after another separated by commas, the first one being alpha. Going \alpha will create the Greek letter alpha, and doing \omega with a capital will create a capital omega. You can then use this variable in other figures and all, which we will get to when we do plotting. If we were to do fprintf with the same command, it would print \alpha to \omega because the special / character doesn't work in the command window. It really only works in figures. We could also use the sprintf command to modify font characters for inclusion on figures. That's where the sprintf command comes in. It's going to be really useful for formatting figures and graphs when we get to that. Most special font characters also will not work correctly if you print them to the command window. For example, we'll just print the equation E sub m equals mc squared. To do this using the sprintf command, you would write energy, which is a variable that you want to store it in, is equal to sprintf of our text string, which is E, the underscore means sub equals mc, the caret means squared. And if you were to place this in a figure, you would get the nice formatted equation that we like. If you were just to print the variable energy as a text string, you are not going to get the formatting to occur. So the formatting only occurs in figures. When using the sprintf command, it will not appear in your command window. So let's work on an example. We need to write a single line of MATLAB code to accomplish a stated task. We want to assume the percentage of sensors that are operational is stored in a program in the variable eta. We want to print the following message to the command window. We want to print the robot sensors are 80% functional. So we're going to use the fprintf command because we are printing to the command screen. The text we want to say is the robot, so note we need 2 quotation marks here, 2 apostrophes here to create the apostrophe. The sensors are, this is where we're putting in our variable, so we want to print the percentage that is stored in the variable eta to 0 decimal places. So we're going to do percent 0.0, so no decimal places, F. Then we need 2 percent signs to generate our percent sign, and then functional, and then we're using the variable eta to retrieve our percentage. Assume a program contains the following information stored as scalars. We have n1 and n2, each containing a single value. We have a calculation that occurs that is n1 times cosine of pi e to the minus 5 n2. We want to print the following in the command window. So we want to print ncalc equals x.xxxx, where this is the format, not the letter x's, when n1 equals y.yy, so this is the formatting for n1, and n2 equals, this is the formatting for n2. So what do? We're going to use, again, our fprintf command. We're going to type in the string that we want to display. So we have ncalc equals. We're going to format to 4 decimal places for our first variable. We're going to continue on with our text string when n equals, then we're going to format our second variable to 2 decimal places, and then n2 equals, and we're going to format that to 1 decimal place in scientific notation. And then we're going to list the variables in the order that we want them to appear in our text string. So that would be ncalc, n1, n2. Assume a variable quote contains the company name as it is in the first element and an employee's first and last name in the second and third elements, respectively, in the machine part that they are interested in obtaining a quote for as the 4th element of a cell array. We want to print the following in the command window, where the symbol is indicating a line in MATLAB shown to illustrate it. And the company name are indented 1 tab left from the margin. So how do we do this? Well, we're going to use our fprintf commands, and then we're going to start with, we have the individual, then we want to go to a new line, then we want to insert a tab, and then we want to insert text, comma, insert more text, and then go to the next line. Then we want to insert a tab from, we want to insert some more text, go to a new line, has requested a quote on, finish it with the rest of the text of what they have requested their quote for, and then insert 2 new lines. What variables are we inserting? So we have our variable quote. We want, the first thing we need is the individual's last name. So the last name is stored in the 3rd entry of quote. Then we need the first name, which is stored in the 2nd entry of quote. Then we need their company, which is stored in the first entry of quote, and then we need the company, which is in the 4th end. So we want to create a following text string using the sprintf command to be located on a graph. F is equal to ax squared plus bx plus c. So say I want to put my equation on a graph. I want to assume a, b, and c have been defined in the program. We want to show a as an integer, b with 2 decimal places, and c should be shown in scientific notation to 1 decimal place. What are we going to do? We're going to create our variable te. We're going to use our sprintf command, and we're going to say f is equal to 0.0f for a, x squared, and we're going to put the square in curly brackets, and then we're going to put 2 decimal places, and then for our second variable b, plus 1 decimal place with scientific notation, and then do a plus b plus c. The reason there are curly brackets around the 2 is if you need to group exponents together, you have to use curly brackets and not regular parentheses, because it's going to turn those exponents into a cell array to lump together. So let's try this one using sprintf. We want to generate the equation f is equal b e to the ax, where a is an integer and b should have 3 decimal places. So we're going to use our sprintf command again. F is equal to 0.3f because we want 3 decimal places for b, and we have e to the 0.0f for a, x, and again I'm putting those in curly brackets so they all go together instead of just parentheses, and then a comma b. I believe the reason A is first is because it's going to format the exponent before it formats anything else, because the order of operations still stands, but I am not sure, and we'll check on that. The last thing we're going to go over is communicating with Excel. So we're going to be able to read a workbook information and text from Excel file into MATLAB. We're going to identify data types that are created when we import an Excel file, and we're going to store information generated in a program into an Excel file. Basically, we're going to use XLL read and XLL write. Believe these functions still work. There's been a few modifications in MATLAB recently. But the basic things are, if you have a variable equals XLX read and you put in your workbook, your file name, and your sheet name, it will read the data that is listed on that sheet. So in default, if I do XLS read and I just list the file name, it's going to read the data in the first sheet. If I have multiple sheets, I have to specify which sheet I want to read. In this one, where we have data variable and text variable for our XLS read command, all of the numerical values in Excel worksheet are a floating point scientific integer, and the text variable will be all of the text, including dates and other text. You can also import data using the Import Data tab. So if you go home to Variable, Import Data, you can select a workbook or a text file from the list. Once you choose your folder and directory, you can import your data. The import wizard will choose the type of data that you wish to import. Are you importing a matrix, a cell array, and then you can choose your import selection. How do we write data to an Excel file? Well, assume I have A equals 1, 2, 3, 4, so I made a matrix. It's defined in MATLAB's workspace. I can use XLX write, and then I put in the file name .xlsx, comma A. So this is the file name where I want to store A. You can also examine your file by right-clicking and clicking open outside MATLAB, and it will open a MATLAB Excel interface. So we have some advances for XLS write. Is you can write the file name, the variable, the sheet, and a certain cell. You can put in headers, and then you can write data from MATLAB. You can put in the file name with data from MATLAB and a certain variable. You can continue to add headers by stringing them together. If a workbook already exists, you may get a warning message that you are adding data to it. This is normal, correct, and expected, but you can add to workbooks that you have. So we'll go in and work at a few examples of these because it is handy to go from Excel to MATLAB. I believe using the input wizard is a little bit easier now than using the XLX read commands. Yeah. Next time we're going to start actually going over Excel.